Welcome to BCMSN Lab number 4. In BCMSN Lab number 4, we're going to take a look at how we can configure a Catalyst switch port to support a connection to a Cisco IP phone. A Cisco IP phone can be sending voice into our network as well as data. That's because some of our Cisco IP phones have an extra PC port that we can use to daisy chain a PC into that phone. So we want to start off by reviewing how a Cisco IP phone can prioritize the voice traffic using different markings. Our specific focus is going to be down at layer number 2 with COS markings. We want to take a look at the syntax that will allow us to configure that Catalyst switch port to support different VLANs. One VLAN for the voice frames coming from that IP phone, and another VLAN for the data frames coming from that attached PC. And the PC that's attached to that phone, it may be capable of marking frames that it sends into the phone with a priority marking. We may or may not want to trust those PC-generated markings, and we'll show you how we can influence those by remarking those priority markings coming from an attached PC. Also, we want to take a look at how we can take voice traffic and put it into a separate queue, a separate storage space inside of our switch, so that it has priority treatment and it gets to go out ahead of other frames in the switch. And finally, we want to verify our configuration, make sure that we are paying attention to those priority markings coming from our IP phone, and making sure that we're giving priority treatment to those voice frames. Consider the topology on screen. Notice that we can have a PC sending traffic into the data VLAN, and that PC can be plugged into a Cisco IP phone. Simultaneously, that Cisco IP phone can be sending traffic from a voice VLAN, and traffic from both of these VLANs travel into that Catalyst switch on a single port, an access port. Let's take a look at the syntax we're going to use to start optimizing this port. First of all, we want to globally enable quality of service on the switch. We do that with the command MLS for multilayer switching, QoS. That globally enables quality of service features on that switch. And even though we're sending traffic from two different VLANs, we actually want to configure that Catalyst switch port as an access mode port as opposed to a trunk port. We do that with the command switch port mode access. We want to tell that port what VLAN it is a member of when it is sending data traffic. We can do that with the command switch port access VLAN, followed by that VLAN identifier. But remember, we may be daisy chaining this PC into a phone into the switch, and while the PC is using the access VLAN, the phone is using the voice VLAN. Let's see how we can specify the identity of the voice VLAN. Sometimes we call this the auxiliary VLAN. We do that with the command switchport voice VLAN followed by the VLAN identifier. And the IP phone does a great job of helping us give priority treatment to our voice frames. By default, it is going to mark our voice frames with a marking called a COS, a class of service marking, a COS value of a 5, a very high priority marking. And you may have learned in your QoS studies that the Cisco IP phone is also marking at layer 3 with something called a DSCP, a differentiated services code point value of 46. Which is sometimes referred to as a DSCP value of EF, expedited forwarding. But our focus in this lab is down at layer 2. That's what we're going to be configuring our Catalyst switch to trust. We want to trust those layer 2 priority markings. A potential challenge, though, is this. That PC attached to the phone, it may be capable of marking frames with a priority marking. Maybe we do not want to trust the marking coming from the PC. Well, by default, the Cisco IP phone is going to remark the frames coming from that PC with a COS value of 0. But maybe we want to override that default behavior. Maybe we do want to give a certain level of priority to frames coming from that PC. Let's consider an example. Let's say that the PC on screen has been configured to mark frames with a layer 2 COS value of a 7. However, instead of just using the Cisco IP phone's default behavior and overriding that COS value of a 7 to a COS value of a 0. Let's say that we wanted to assign a specific COS value. We have that option. We could, as we see in this example, say that frames coming from that PC had a class of service marking of a 2. Let's see the syntax to set this up. First of all, we want to say that we want to trust those COS markings, those layer 2 markings. We can do that with the command MLS QoS trust COS. That will help our switch in queuing frames based on those markings, but perhaps we do not want to trust just any COS marking. We only want to trust COS markings that originated from a Cisco IP phone. We can do that. We can use the command MLS QoS trust device Cisco-phone. That will only trust COS values originating from a Cisco IP phone. And also recall that we said we may want to manipulate a COS value originating from a PC. We could override that COS value coming from a PC and remark it. With this command, we could say switch port priority extend COS followed by that COS value. By the way, the valid range of COS values is 0 through 7. However, Cisco cautions us not to use 6 or 7. Those are reserved. So the highest COS value that we should ever use to mark a frame is a 5. That's what the Cisco IP phone uses to mark voice frames. Let's now go out to a Catalyst 3550 series switch and set up this configuration. Let's go into global configuration mode on our Catalyst 3550 switch and globally enable quality of service features. We do that with the command MLS QoS. MLS for multilayer switching. And on this particular switch, I have a Cisco IP phone, a Cisco 7940 IP phone specifically, connected to interface gigabit 0/1. So let's go into interface configuration mode for interface gigabit 0/1, and let's do something that might be a bit surprising. Even though we can send traffic from 2 different VLANs coming from that IP phone into this switch port, one VLAN representing the voice traffic itself, and the other VLAN representing a data VLAN, in other words, the VLAN of a PC plugged into the PC port on that phone, even though we can send traffic from 2 separate VLANs, one might think this is a trunk port, but we are going to configure this as an access port. We say switch port mode access. Now let's specify the data VLAN. This would be the VLAN for the traffic coming from the PC attached to the phone. Let's say switch port access VLAN. We'll make that VLAN 10. And for the voice VLAN, sometimes we call that the auxiliary VLAN. Let's set that to a VLAN of 20 with the command switch port voice VLAN 20. Next, we want to instruct this switch port to trust COS values, class of service priority markings. This is a layer 2 priority marking. What we're going to do is make our queuing decisions based on these layer 2 markings that come in on the frames coming into this port. Let's say that we wish to trust those layer 2 COS values with the command MLS QoS trust COS. However, let's take it a step further. Let's say that we do not wish to trust just any COS value. Maybe that value is coming from an untrusted end-user station. What we could do instead is say, yes, I want to trust those COS values if and only if they're coming from a Cisco IP phone. We can be very specific about which COS values we trust. We can issue the command MLS QoS trust device, and if we give some context-sensitive help, notice we can specify Cisco-phone. So the question comes up, how do we know we're attached to a Cisco IP phone? And the answer is CDP. The Cisco Discovery Protocol can allow the switch port to learn that it's connected to a Cisco IP phone. And let's think about that PC that's attached to the Cisco IP phone. By default, the Cisco IP phone is going to remark any layer 2 COS markings coming from that PC with a COS value of a 0. In other words, we do not trust the COS markings coming from that PC. But let's imagine that that PC is an executive's PC. We do want to give it some level of priority, certainly not as high as voice. Voice is going to be marked by that IP phone with a default COS value of 5, but let's say that we wish to give the frames coming from that attached PC a COS value of 2. We could do that with this command. We could say switch port priority extend COS, and let's give the COS value of a 2. Just to verify that we truly are connected to a Cisco IP phone, let's do this. Let's go out and do a show CDP neighbor command. Notice this. Not only are we attached to our upstream router, router R1, but we're also attached to an IP phone. How can we know this is an IP phone? Notice the SEP. That stands for Celsius Ethernet Phone. Celsius, that's the company that Cisco originally acquired to get into the world of IP telephony. So we are indeed attached to a Cisco IP phone. Even though we have configured our data VLAN and our auxiliary VLAN, and we've told our Catalyst switch port to trust COS values, we still have a challenge. And that challenge is, by default, the COS value of a 5, that's what our voice frames are marked with, those COS values, they're being placed into queue number 3. In fact, let's take a look at the default placement of various COS values. COS values of a 0 and a 1 on a Catalyst 3550, they go into queue number 1. COS values of 2 and 3, they go into queue number 2. COS values of 4 and 5, they go into queue number 3. And finally, COS values of 6 and 7, they go in to queue number 4. The major challenge on a Catalyst 3550 switch, which is what we are using in this lab environment, is this. Only queue number 4 can be used as a priority queue. A priority queue is a queue that gets emptied first, ahead of the other queues. We want our voice traffic to get priority treatment and go ahead of the other traffic. So what we want to do is manipulate this default COS mapping. We want to place COS values of 4, 6, and 7 in queue number 3, and we want a COS value of a 5, our voice frames in other words, we want that to go in to queue number 4. Let's see the syntax that can make this happen. In interface configuration mode on a Catalyst 3550, we can say WRR-Q COS-map followed by the queue number. That's going to be queue 1, 2, 3, or 4. And after we specify the queue number, we specify one or more COS values that we can use to place in that queue. Let's go back out to our interface to see how to set this up. Let's now influence which queues our different COS values are going to go into. To do that, let's get back into interface configuration mode for interface gigabit 0/1, and as we mentioned earlier, by default, a COS value of a 5. That's the COS value of a voice frame coming from a Cisco IP phone. By default, it's going to go into queue number 3. And on this 3550 platform, only queue number 4 can be made into a priority queue. So let's influence this port to put COS values of 5 into queue number 4, while we put COS values of 4, 6, and 7. Let's put those into queue number 3. Here's the way we can do that. We can say WRR for weighted round robin, WRR-Q COS-map. We next specify the queue number. We have 4 queues on this Catalyst 3550. Only queue number 4 can be converted into a priority queue, or sometimes we call that an expedite queue. Let's say COS map 4, and now we can specify the COS values that we wish to put in to queue number 4. What do I want to put into queue number 4? I want to put COS value 5 into queue number 4. What about the COS values that were already in queue number 4? 6 and 7, I want to put those into queue number 3, along with a COS value of 4. So let's do that. Let's say WRR hyphen Q COS hyphen map, and this time I want to put into queue number 3 frames that have a COS value of a 4, a 6, or a 7. Finally, let's tell the switch that queue number 4 is a priority queue. In other words, frames deposited into that queue get to go first, ahead of everyone else. We can do that on a Catalyst 3550 platform, and this does vary by platform, but we can do this on a Catalyst 3550 platform by saying priority hyphen queue out. Let's now give a couple of commands to verify our configuration. We can say show MLS QoS interface, followed by the interface identifier. This time it's gigabit 0/1. That's what our IP phone is plugged into. Notice this, we are trusting COS values, but not just any COS value, specifically only COS values that came from a Cisco IP phone. Here's another great command that can show us how we're mapping COS values into those queues. We can say show MLS QoS interface. We give the interface identifier of gigabit 0/1 and say queuing. And notice this, a COS value of a 5 is being placed into queue number 4, while COS values of 4, 6, and 7, they're being placed into queue number 3. And remember that we made queue number 4 a priority queue. And now that we're done, let's copy our running configuration to our startup configuration with the command copy running -config startup-config. Let's review where we have been in this lab. In BCMSN lab number 4, we've been taking a look at how we can configure a Catalyst switch port to support a connection to a Cisco IP phone. We began by reviewing some of the different priority markings that a Cisco IP phone can use to identify voice traffic as very special traffic. We talked about the syntax that would allow us to configure a voice VLAN to carry the voice traffic coming from the IP phone, and a data VLAN to carry the data traffic coming from a PC attached to the Cisco IP phone. We mentioned that that PC may have its own COS markings coming into that phone, and we saw the syntax that would allow us to override those markings coming from the PC. Another challenge we had was that with the default settings on a Catalyst switch, on a 3550 specifically, the voice frames were going into queue number 3. However, only queue number 4 could be used as a priority queue. So we did some manipulation of how our COS values were mapped to our queues, and then we concluded this lab by taking a look at a couple of verification commands to make sure that our switch port was trusting what we think it was trusting, and to verify how our COS values are being mapped into our queues.